This is chapter 13, set C, number 7. It tells us a coin is tossed 3 times. Part A says find the probability of getting 3 heads. So whenever I do a probability, I'm thinking in my head, how am I going to get what I want? So like to get 3 heads, that means my first time would have to be a head, and the second time would have to be a head, and the third time would have to be a head. All 3 of those things have to happen for me to get 3 heads. So I need a probability of a head and a head and a head. Well, anytime I have an and, I'm just going to multiply the probabilities. So first I want the probability of a head. Anytime I flip a coin, if it's a fair coin, the probability of a head should be 1/2 or 50% or 0.5, whatever you want to do. Then when an and, I'm going to multiply. And then I want another head, which is still 1/2. When we toss coins, it doesn't change from time to time. It's 1/2 every time, no matter what. And to get one more head, I'm going to do 1/2. So every time to get a head is 1/2. I multiply them all up, I get 1/8. Okay, now part B says, what's the probability of not 3 heads? Well, this not 3 heads is basically saying, in part A, we found the probability of 3 heads. Now let's find in part B everything else. Anytime you want the probability of everything else, that's called the complement rule. So the probability of not 3 heads is just going to be 1 minus the probability of 3 heads. So we already know that what this probability is, and then we want just the probability of not that, so everything else, and so that's why we do the 1 minus it. So we'll do 1 minus the 1/8, which gives me 7/8. So a 1/8 chance that we get 3 heads, a 7/8 chance that we get anything else. Okay, part C, probability of at least 1 tail. The problem when you do something like this, okay, is you might start trying to do different things that are probably going to not be right. There's only one good way to do the probability of at least 1 tail. The reason why is if you think about how can you get at least 1 tail? Well, if I start listing out the outcomes, I could get a head, and then a tail. Or I could get a head, tail, head. Those would all have at least 1. Or I could get a tail, head, head. Or maybe I could get a head, tail, tail, or ... There's a lot of different ways to get at least 1 tail. This is going to take you forever, and we're only doing 3 coins. Okay. What if you are trying to do it 10 times or something? There's no way you're going to want to list out all the ways you can get at least 1 tail. So we're going to use the complement rule. So much easier way to do it. Oops. Sorry, I'm having to use my bad pen today and it doesn't erase. Is you're going to use the complement rule. You're going to do 1 minus the probability of no tails. Every single time in probability, if you have the probability of at least 1, you're going to want to do 1 minus the probability of 0 or none. Because those are complements, it's so much easier and faster to do. So to do this, it'll be 1 minus, okay, now the probability of no tails. Well, how do you get no tails? The only way to get no tails is if you have heads and heads. Oops. Sorry, this pen just does not work. Heads and heads. Okay. This is the only way to get no tails. Now, heads and heads and heads, we found that. That's up here in part A. So we don't have to calculate it again, although we could just doing the exact same thing. So we'll do 1 minus 1/8, which again gives me 7/8. So that's the probability of at least 1 tail. Now, if you want to do part D, you're going to work it out exactly the same way, except instead of saying no tails, it'll be no heads.